that this lecture is recorded. I'm going to open the data file. So today is lab 7 optimization. Can someone confirm that you can hear me and you can see my computer? I'm going to type a message. All right. Can somebody confirm that you can hear me and see we can hear and hear? Thank you so much, Eric. Thank
Yes,
you.
I can see.
Thank you so much. I can also hear you. That's great.
I can see your screen.
Okay, excellent. Thank you. We have 3 minutes. I'm going to open the Excel data file. That is not the one. Lab 7. All right. Lab 7. I strongly encourage you to follow my steps. So please go to Sakai, open the Excel file, and follow my steps. All right, it is 3 o'clock. I double check the technology. We can hear each other and you can see my computer. Are there any questions before we start? Any questions? I'm using Mac computer to do demonstrations, and I'm using iPad to answer your questions. If you have questions in the chat areas, I also encourage you to ask your question directly. Just speak up, okay? I will stop and answer your questions. All right, so hope you have this data file opened, and where is my instruction here? This lab is about optimization. And the question we are going to go over is also introduced in class lectures, okay? So this is a question about a manufacturer to produce two snow ski models, Jordana and Deer Crest, okay? And this same information is also available on this Excel data file. So those are the information, okay? So basically, this manufacturer produce two products. One is Jordana, the other is Deer Crest. We want to know how many units of Jordana to produce and how many units of Deer Crest to produce such that we maximum our profit. Okay, maximum our maximum production, okay, profit. And this manufacturer has two departments. One is fabrication department. The other is finishing department, okay? And the information said the fabrication department has 12 skilled workers. Each works 7 hours a day. So how many total hours in fabrication department? So it is 12 people times 7 hours. Is that right? So this number represents 1 day you have these hours available for fabrications. And for finishing department has how many people? 3 workers and 7-hour shift. So 3 times 7. 3 workers in finishing department, 7 hours per day. Okay. And now each pair of Jordana skin requires 3.5 hours in fabrication and 1 hour in finishing. So 3 hours for fabrication, 1 hour for finishing, okay, for this product, Jordana. And for Deer Crest requires 4 hours fabrication and 1.5 hours finishing. Okay. And also we have market mix. It is said this company, there are two. I'll go back to the Word document. There's a market mix here. So the number of pairs of Deer Crest must be at least twice number of Jordana skis. Okay, so number of Deer Crest must be at least twice. So this is market mix. So based on this information, we can write down I will explain -2 here and 1 here, so that we have, maybe I want to use my OneNote to do some illustration. Here. So this is our lab 7. I'm going to add a page. Lab 7. And I'm going to copy all the instructions here. Maximize my screen. So this is the requirement. Okay, this is the requirement here. And I have continue. Maybe I will just use to select this way. Try to Control C, Control V here. See if this works. Okay. All right. So now the market mix. Number of pairs of deer crest. Okay, so if number of deer crest use X, number of Giordani use Y. Okay, so how do you use algebraic expression to illustrate this market mix? Must be at least twice. So X must be at least means greater equal to 2Y. Do you agree? So X greater equal to 2Y. So if this is true, X greater equal to 2Y, and when you move 2Y to the left-hand side, you get negative 2Y. Negative 2Y plus X greater equal to 0. Okay, greater equal to 0. That is the coefficient for Y is negative 2. The coefficient for X is 1. Okay, this illustrates how do I get negative 2 and 1 in the Excel here. Did you see here? Negative 2 and 1. Because here I'm using greater equal to right-hand side, this is 0. Okay, so double check, yes. So any questions so far? So far, we didn't do anything. We just enter the data based on the descriptions of given requirements. We just enter those data here. Okay. So any questions? Any questions? I will just maybe copy this into my OneNote in case I need to do some annotation. Okay. So we didn't do anything, we just entered the data. Once we enter the data, now our question is, suppose we produce X units of Giordani and Y unit of deer crest. And our objective function, so, and also the given condition said here, when you sell 1 unit of Giordani, what is the $50? You make $50. Okay, the sale price is $50, and the sale price for Deer Crest is $65. So, any questions so far? Okay. So now, objective function. So this is a 50. The unit sale price is $50. And the unit sale price for Giordani is 65. So the objective function, so how many total sales will be produced? You use 50 times x, 50 times x, and plus 65 times y. X represents number of units for Giordano. Y represents number of units for Deer Crest. Any questions? This is my objective function. And I want to maximum this function, maximum, because I want to make most profit. Okay, so how do I use Excel to realize 50x plus 65? In Excel, you use sum product function. The function name is sum, S-U-M, and then product. It is one word in Excel, sum product. My mouse is not that smooth. So sum product function. Okay, to do what? To do 50x plus 65y. Okay, so now I'm going to use Excel equal sum product, opening bracket, array 1. So this is array 1, comma. Next array is this number here. I cannot put x and y because this is Excel. Okay. So any questions? Okay. So right now it is do not have number because I didn't put any number in these two columns, in these two cells. It will give me the number later on. Okay. All right, so this is the objective function. And what is our constraints? The constraint is 3x plus 4y must be smaller or equal to 84. Do you agree? 3x plus 4y smaller or equal to 84. Going to write down here. That is one of my constraints. Okay. So one constraint is 3x plus 4y. Again, 3x plus 4y is a sum product. Okay. Smaller or equal to 84. And another constraint is 1x plus 1.5y smaller or equal to 21. So 1x plus 1.5y smaller or equal to 21. The last constraint is the market mixed. So negative 2x plus y, negative 2x plus y greater or equal to 0. This is the market mix. Okay, so each of these expressions can be realized using sum product in Excel. Okay, using sum product in Excel. So I'm going to use this one equal sum product. This array, this one, and another array is here. Because I want to copy down the formula, so this cell reference B5, C5, I am going to use absolute cell reference. Okay, so I'm using mark. I just press Command T, letter T, Command T give me the absolute cell reference. If you are using PC, F4 button, F4, or you can manually add $sign to those cells. Okay, so this is the sum product, means 3x plus 4y. Okay, so because I use absolute cell reference, I can copy down the formula. Okay, so I'm going to copy down the formula. Okay, so now what I'm doing now, I'm doing preparation to find out what is X, what is Y. And how do I find out? Use Excel solver. So you go to data and you have solver. If you do not have solver, do the same produce the same procedure as how do you get data analysis, similar steps. Okay, so I'll go to solver and then set objective. Oops. Looks like close. Don't save. Maybe I have other window. This is something I did this before a few days ago. It put out this one. That is what I don't want. Okay, I'm going to try to read. I go to data, go to solver. Set objective to maximum. So this one is in D7. Okay, this objective to maximum by changing the cell B5 to C5. Okay, because I already did this, I'm going to delete this constraints. Okay, and then add constraints. Quick add button. Objective cell must be there. So this is not set objective is D7. Okay, and then add constraints, cell reference. So those two columns say smaller equal to these two cells. And then quick add button on equal number. Constraints. That's fine. Then I'll quick add button. Give me this. I will cancel, redo it. Add constraints. Add. Maybe I want to do one by one. Okay. Oh no, this one. Not these two. Smaller equal to this right hand side. Left hand side. Smaller equal to right hand side. And then quick add button to add market mixed. This cell, this time it is greater equal. See, greater equal to this cell. Quick OK button. Okay, and make sure solving method is a simple LP, simple linear programming. Okay, and check out variables is non-negative. And then quick solve button. Okay, quick OK button. See, you automatically get these two numbers. So how many units you produced? 5.25 units for Jordanler. And Deer Crest, you need to produce 10.5 units. Okay. Any questions? Any questions so far? Again, you need to practice by yourself. Maybe 1 time, 2 times, 3 times to make sure you are comfortable and confident. Honey, please be quiet. Okay, sorry. I got one question. Can you go over the last part again? Which one is last part? Does the solver? Okay, it is here. Go to use quick the solver. And then set objective D7 to maximum by changing variable cells B5 to C5. Select B5 to C5. Add constraints. So our constraint is the left-hand side in D10 to D11. D10 to D11. Smaller equal to F10 to F11. And then market mix. D12 greater equal to F12. And then check out. Make unconstrained variables non-negative. And simple linear programming is selected. Then you click solve. Okay. In order to get the correct result, you need to make sure all the formulas you type in is correct. For example, we type in sum product, that formula. Okay. Thank you, Iman, for your questions. Any other questions? Any other questions? We have chance to do next question. We are going to repeat ourselves for this procedure, okay? So no worries if you didn't get it first round, okay? So this is this question, part A and part A. We did part A, okay? The linear model, I actually use OneNote to do the linear model. So those are my linear model. Objective function I listed here. Then right-hand side, left-hand side. So I'm going to, just to be clear, this part is a linear model. Okay, this part is linear model, the one I highlighted. This is linear model. And then we use Excel, solved this linear model. Okay, so we finished question A. Question B. If the manufacturer decides to change the price for Deer Crest to $75 per unit, in sheet 2, set up the model and solve it. Okay, so let's go to the sheet 2. Sheet 2. Everything is the same. We just need to change this $65 to $75. Change to $75. Okay, I'm going to maybe highlight this number. This the number I highlighted. Okay. So first step, what is objective function? Sum product. See, I'm repeating myself, guys. If you lost in the first part, I'm restart everything all over again. Okay, so equal sum product. Sum product. And then this is this one, comma. And then this array. I pause for a moment so that you see my function. Sum product. Okay, enter. And now do the sum product again, sum product. Okay, select this one, comma, and then select the yellow background, this cell. I'm using mark, so I will press Command T to change to absolute cell reference. Okay, and now copy down the formula. Okay, and next use solver. Go to data, solver. Objective D7 to maximum. By changing cell B5 to C5, that's correct. Other constraints, those constraints are the same, so I want to change it. The same constraints as before. Okay, and then I'll click Save button. Okay, Save button again. So even if I change this number, the number of units, the final answer didn't change. However, the value for objective function has been changed. See, it becomes 1050. In the fourth round, this one you get 945. Okay. And in the lecture or in the textbook, it gives you the explanation why the objective function changed, but the number of units need to produce does not change. Okay. So this is this question. We finished D, B. Okay. Question C. One of the interns have decided it would much better just to focus on market mix and remove the finishing and the fabrication constraints. So now let's remove the constraints. Just use market mix to solve the model. And what is your observation? Okay. So this is a question C. So now this is a worksheet C. Okay. All right, so we repeat ourselves again. Okay, so this time I'm going to speed up. Equal sum product. And this is the array, comma. And then B5, C5. And now the market mix equals sum product. Use this array. And then this time I do not need absolute cell reference because I do not copy down the formula. Okay, so this is my constraints, just one constraint. So go to data, solver. Set objective D7 to maximum by changing cell B5 to C5, that's correct. So now I'm going to delete the constraints to just add one market mix. So D12 greater equal to D12 greater equal to F12. Click OK button. And make sure non-negative is checked out. Simple linear programming is selected. And then click solve. Click OK button. Okay. And see, you don't have solution here, actually. Okay. Because you removed the constraints. So this is this one. Let me double check something. Any questions? Question D. If you, by mistake, you have used greater equal sign in fabrication constraint, find out what will occur, and also run the feasibility report. Okay, run the feasibility report to identify where the issues may arise. So fabric can change to greater equal. So go to next one. Fabric can change to greater equal sign. Okay, this one changed. Everything else is the same. So this time we'll repeat ourselves again. Okay, objective function equals sum product. So select B5, B7, C7, comma, B5, C5, closing bracket. And now left-hand side equal to sum product. B10, C10, comma, then C5, B5, C5, absolute cell reference, because I'm going to copy down the formula. So now I will copy down the formula. Okay. Next, I'm going to use the solver, data solver. Objective function D7 to maximum, correct? By changing the cell B5 to C5, correct? And then this time I'm going to delete the constraints to rewrite down the constraints. So add, so D10 greater or equal to F10. Then click add button. D11 smaller equal to F11. Click add button. D12 greater equal to F12. Click OK button. Okay. Now make sure non-negativity is selected. Simple LP is selected. Then click solve. And also produce feasibility report. Check out this one. Okay. And click OK button. Okay. So after you click OK button, where is the feasibility report? It is here. This is feasibility. See, something violated. Okay, this constraint fabrication. This one violated. Okay, so this is the feasibility report because you change from smaller equal to greater equal sign. Okay. We only have limited resources. Remember, when you change greater equal to 84, means it could be 100, 200, 1,000. It is not realistic. Okay. So any questions? Oops. Try to open my Word documents. Okay. So in the original solution, the values of decision variables, are they practically possible? What is the solution? Okay. Remember the number, the original solution here. Here we get 5.25. How come you have 5.25 as units? It is not practical. You can either have 5 units or 6 units. And this one, you can either have 10 units or 11 units. Okay. So to be practical, maybe you produce 5 units of Jordana and 10 units of Deercrest. Okay. So any questions? So this is question 1, has multiple parts. Question 2. Okay. Holiday Meal Turkey Ranch is considering buying 2 different brands of turkey feed and blending them to provide a good low-cost diet for its turkeys. Okay. There are 3 ingredients, ingredient A, B, C. Brand A, brand 2, or brand 1 and brand 2. Okay. Minimum monthly requirement per turkey. And also the cost per pound for brand A is 2 cents, for brand B is 3 cents. Set up linear model to identify how many pounds of each brand of feed should purchase, and then solve it using solver. Okay, so this is this question. So now I'm going to, the worksheet is here. Okay, try to increase the font size. And then I'll copy this into OneNote so that I can make annotation. So suppose we want to produce X units of brand 1 and Y units of brand 2. So the cost for brand 1, that is 2 cents, right? And 3 cents for brand 2, double check. Yeah, 2 cents, 3 cents. Okay. And then you have, maybe I will fill out here. Translate those data into Excel. So you have A, B, C. So you have 10, 5, 10, 4, 3, and then 0.5, 0. Okay. On the right hand side, you have monthly requirement per turkey. So you have 90, 48, and 1.5. 1.5. Okay. So those are some given number. Okay, some given number. So again, I'm going to copy this one. Just try to write down the model first, okay? Because in your final exam, you may have similar questions ask you to write down the model. So suppose this is X unit for brand 1, Y unit for brand B. Brand 2, objective function cost is, remember you have 2 cents for brand 1, 3 cents for brand B. So objective function equal to 2x plus 3y, 2x plus 3y, that is the objective function. Okay, f equal to 2x plus 3y. And then left-hand side here, you should have 5x plus 10y greater or equal to 90. 4x plus 3y greater or equal to 48. 0.5x plus 0y greater or equal to 1.5. So this is your constraints. Okay. Once you set up this model, the question is what is x, what is y? So that is the question. Okay. So obviously we are going to use solver to solve it. Okay. Typing this is 2 cents, 3 cents. Now go to data, solve. Have to type in function first. So objective function equals sum product cell B7, C7, comma, then B5, C5. This is objective function. And the constraints equals sum product. So B10, C10, comma, B5, C5, absolute cell reference, because I want to copy down the formula. Now copy down the formula. Okay. So now solve. Set objective function D7 to, this time we choose minimum because it is cost. We want to minimum the cost by changing the variable B5, C5, correct? And then the constraints, I click add button. So this left-hand side, I select them all. Greater or equal to right-hand side, select them all. Click OK button. Make sure non-negativity is checked. Make sure simple LP is selected. Then click solve and click OK button. So this is your final result, 8.4 and 4.8. Okay. So that's the optimization. In summary, in this lecture, we write down the model first, okay, and then we use Excel solver to solve it. Okay. Any questions? So I'm going to take attendance. And you are welcome to ask questions. We have a few minutes. All right, I took the attendance. We have a few minutes left. Any questions? So I'm going to stop recording.